Okay, so this is question number 9, pre-cal 30. We are sketching without technology, so what we need to do is we need to whittle this down. We need to factor it fully, identify the degree, the leading coefficient, where the x-intercepts are, the y-intercept, and then sketch it, okay? So first thing we need to do is to factor this. Now it's a Quartic, okay? It's not easy to do this by sight, so we're going to have to try and pick up some things, although I see that there's no constant here, where there's a constant of 0. Do you guys see that? So actually that whittles this down right away. We can rewrite this as, because you can take an x out of each term, you see? So let's write this as x times x cubed minus 4x squared plus x plus 6. So now we've factored an x out, which is easy to do. That's great. And now we can just work on this cubic function now. Probably a good idea to, let's do factor theorem and let's do synthetic division and get practice with that. Okay, so I'm going to try binomials that look like this, maybe x plus 1 or x minus 1 or x plus 2 or x minus 2 or x plus 3, x minus 3, x plus 6, x minus 6. So these are the ones that could be factors of this one. So let's start with something easy. This is the easiest one because you just put a equals 1 into the polynomial here to find out if you get a remainder of 0. So I'm going to put this p of 1, and what do I get? 1 minus 4 plus 1 plus 6. That's 2 minus 4 is negative 2 plus 6. Does that equal 0? Doesn't look like it. Okay, let's try negative 1. That's the next easiest one. That's from this factor.
Alexis Schofield, you're needed as a PM solution.
So this is going to be negative 1, still minus 4, because negative 1 squared is positive 1. And then this is minus 1 plus 6. Oh, this is looking good. Look at this. That's a negative 6 plus 6. So that looks like it's 0, right? Why did I put an x there? Just not equal to 0. Okay, so I've got my first one. Looks like x plus 1. So let's practice synthetic division, which I'm going to try to factor this polynomial. I want to make sure that I have coefficients for each term in decreasing order of x. So that's a cubed, squared to the 1, and then constant. So that's great. So I'm going to put this value, negative 1, on the side of my little elongated L there. And I'm going to put the coefficients for my polynomial up here on the top row. So 1, negative 4, 1, and 6. I'm going to put a box underneath the last one because this is going to remind me that that's going to be the remainder that's in there. And this should be 0, right? Because I've done this already. If I've done this correctly, that should be 0. I'm even going to put it there just to make sure that lines up. Alrighty. So we drop the 1 and we multiply. Negative 1 goes there. I add, that's negative 5. I multiply, that's positive 5. I add, that's 6. I multiply, that's negative 6. I add 0. Looks good. Okay? So that means that this polynomial up here has been broken down to x plus 1. That's from this. And also this one, which we'll get to in a second. So I've got fully factored right now. I've got x from here. And I've got x plus 1 as a factor. And then I've got this. So this was an x cubed, right? So this is going to be x squared. Minus 5x plus 6. Okay, so I'll pause there. Let me know if anybody has any problems there. I realize. Yeah, question?
Why are you adding instead of subtracting?
Adding what? Sorry.
In the synthetic.
In synthetic? Okay, so in why am I adding here instead of subtracting? So in the polynomial division, we subtract because we don't change this a value. We would use x plus 1. So you have a plus. And when you have a plus there, then you have to subtract. But if we change it to a negative, which is what we do here, then we can add here.
Okay.
Yeah, because this value, see that's a minus 1. We don't have a minus 1 in the polynomial long division, so that's when we have to subtract. So if we change this one, I can change this to add.
Okay.
And that's kind of the short answer to that question. So yeah, adding, it's easier to add, isn't it? Yeah, so just remember to add here. Okay, good. Any other questions? It's a good question. Yeah.
Is there any significance to bracketing just the x?
No, you don't have to bracket just the x. I just put that there just so we could see that definitely that's a factor, and it's treated the same as the other ones. So I just put next. Yeah, good questions. Anything else? Because we're getting close now. I think we could probably factor this by sight now, right? So I've got x plus 1. Does this work? Are there integral, let's see. So 2 numbers that multiply to 6 and add to -5. Looks like -2 and -3, right? Or -2 minus 3. That looks good. Okay, and those can't be factored any further. That's awesome. So this is our factored version of f of x there, okay? So that's the first section. Questions?
No, my
All right. So it says, without technology, sketch. So some of the things that we're going to need to pay attention to are degree, right? And leading coefficient. So those will dictate the end behavior. So that's going to be important. And I can go back to my original question. That's easy to see. It's right here, you see? That's the leading coefficient. So it's a 1 and it's degree 4, okay? So the degree is 4, the leading coefficient is positive 1, so that's going to help. A y-intercept, we should also look for that, which again, to the original, the constant was 0. So the y-intercept is actually 0. So you can get that from the original question as well, y-intercept 0. And of course the x-intercepts are coming from right here, right? We're going to have a 0, because this is x minus 0, right? Or x plus 0. We're going to have a -1. We're going to have a positive 2 and a positive 3. So let's start putting that graph down there. So we're going to have one at 0. That's from this factor. One at -1 from this factor. One at positive 2 from this factor. And the one at positive 3 from this factor. Okay? I don't know what else we need to know. Huh? Oh, that's looking pretty good. So the end behavior is, we didn't state it, but because it's an even degree and it's positive, think about your parabola, right? That's an even degree positive, so it opens up. So we're going to have going from quadrant 2 to quadrant 1, right? Just kind of like a parabola. But we see that it's going to do some of this in the middle. So, oh yeah, multiplicity. That was the other thing we need to look at. These just happen to all be 1, so they simply cross. Now, can I mention, just if we had something like this, where we had, let's say, 2 of the same, remember, those are not each ones. That's a multiplicity, of 2. So we would have to combine anything like this, just because that helps us to know what happens for this behavior, right? So if this happens where you get 2 of the same, make sure you combine them. Or 3 of the same, make sure it's cubed, that sort of thing. That's not the case for this example though. All right, let's go back and start sketching. We can do it. Okay. So we're coming, I'm going to do this in red. So we're coming up from the top here. We're going to simply cross at -1. You don't know how low you go, doesn't matter. We bend around, we'll cross at 0. We come back around and we cross at 2. And we come back up and simply cross at 3. They're all multiplicity 1. So it looks like something like that. Could very well be symmetrical. We don't know if it's symmetrical like this, but I think that's all you'll need to show me. So there's 4 intercepts, 1 for each factor. And that's kind of how it looks. Now we could check on graphing technology to see, if we have the basics correct. Again, we won't know what this maximum point is. We won't know what this is. We could try and find out, but right now we don't need to know. Look up here. So this is on Desmos. Here's your polynomial. That's what it looks like. We've got -1, 0, 0, 0, 2, 0, and 3, 0. End behavior looks good. Simple crosses. Awesome. Okay, any questions? Okay, so that's Yeah, that's a great question to know how to do. That's got a little bit of everything there, I'd say. All right, good. Yeah.
Will there be questions where to like do like the transformations from last unit with like Quartic?
Transformations, if you ran into any transformations, I'll do another question for you that you have to determine what the A value is, possibly. Yeah, so there's another question I can do for you, but any other questions about this one? All right.